Hello, my amazing Algebra Half students. This is Mrs. A, and I love math. And today we are doing lesson 126 in your Edition 2 book and lesson 117 in your Edition 3 book. And we start off with an example, x squared equals 4. And then we reason that the solution to x is 2 or negative 2. Because if I take 2 and I square the 2, then I do get 4. If I take the negative 2 and I square the negative 2, I get negative 2 times negative 2, which equals 4. So there are two solutions to an x squared equation. And here's our rule. This rule is called the square root property. Anytime we have an equation that is set up with variables squared, so that k, we'll just say it's x squared. X squared, because that's the one you're familiar with. Okay, so x squared is some constant squared. Then x must be plus or minus the constant. So, example. But if I said p squared is 16, then I take the square root of both sides and I get p, and the square root of 16 is 4. But I have to remember it's a plus 4 and a minus 4 because p squared does equal 4 squared does equal 16, and negative 4 squared also equals 16. That's the square root property, and it's really easy. I can even use the square root property when I don't have a perfect square over here. I take the square root of this side and get p. I take the square root of 42, and it's square root of 42. Since 42 is 6 times 7, and neither one of them are perfect squares, that's as simple as I can get it, but I have to remember the plus and the minus. And that's the correct answer for p. So in this lesson, we started learning about solving equations that have a variable squared in it. Now, we're going to learn the Pythagorean Theorem, which is a very, very important theorem that has to do with a variable squared. And it also is only going to work with right triangles, okay? So we have the hypotenuse of a right triangle is the angle that is directly, the side that is directly across from the right angle. These two sides are called legs, and the longest side is called the hypotenuse. And we have this relationship that is always, always true for right triangles. And this relationship was discovered by Pythagoras, who lived a very, very long time ago. But the relationship is always, always true. And it says that the square that is built from the longest side of a right triangle, which would be the hypotenuse, and since this is a square, remember all the sides are the same, so this would be the hypotenuse. This would also be the same length. Okay, so the area of that one is the hypotenuse squared is equal to the area of the squares of that would be on each of the other two sides added together. So basically, since we call the little legs A and B and the hypotenuse C, what Pythagorean's theorem is saying is that c squared, or hypotenuse squared, is always equal to the sum of the squares of each one of the other two sides of the triangle. And that is true and only true for right triangles. So it's so important and always true that we can test to see if a triangle is a right triangle by applying the Pythagorean theorem. And we can also use the Pythagorean theorem, if we know it's a right triangle, to find a missing side. So here we have an example. And notice that we have a triangle with squares put on each side. And this hypotenuse is 5, which means that the square that goes with that hypotenuse would be 25, wouldn't it? And then this one is 4, so the square that goes with that leg would be 16. And then we've got this mysterious little a down here, and we don't know what a is. So we will write this information in the correct spots in our Pythagorean theorem, which the c is always the hypotenuse, so we'll write 5 squared equals, and then the a is unknown, so we'll just write the a squared, plus the b is 4, so we'll write 4 squared. So we end up with 25 is equal to a squared plus 16. Now, can I take away from both sides the 16? Because I'm really trying to get the a squared by itself. Okay, so we're going to subtract 16 here, and we're going to subtract 16 here. And we end up with 9 equals a squared. So now we can use our square root property that we just learned. And we could say, well, we just take the square root of both sides. So the square root of 9 is 3, and the square root of a squared is a. And then we remember a plus and minus. But wait a minute. Because a is a side length, and side lengths cannot be negative. Therefore, we erase the negative, and we realize that that side must be 3. So a is 3, not negative 3, because a negative side makes no sense whatsoever. Now, you have discovered the most famous Pythagorean triple that exists. Okay, so 3, 4, 5 is always a right triangle. Any triangle with the sides 3, length 4, and 5 will always be a right triangle. And you can check that by putting it into the Pythagorean equation here, the theorem, and 5 would go here, and 5 squared is 3 squared plus 4 squared, and that's always true. 25 is 9 plus 16, and it is. Okay, here are 2 examples. Since it's a right triangle, we can use our Pythagorean theorem. So this is a leg, and this is a leg, and this, P, is our hypotenuse. So we would write P squared is 4 squared plus 5 squared. So we would say P squared is 16 plus 25. And 16 plus 25 will be 41. So we get P squared is 41. Then we do use our square root property, which means P is plus or minus the square root of 41. But again, since we're talking about a side length, we take away the little minus sign because we cannot have a minus side. Then we look at this one, and we have a 7 and an unknown leg and a 9 for the hypotenuse. So we would say 9 squared is 7 squared plus m squared. And we have to discover what the side m is. So we know that 9 squared is 81, and 7 squared is 49, plus m squared, which we don't know. So we'll subtract the 49 from both sides of the equation, and we get m squared equals, and then we will cancel. 11 minus 9 is 2. 7 minus 4 is 3. So we have m squared is 32. Therefore, m is plus or minus square root of 32, but we can't have the minus, right? So we just get m is the square root of 32. And that is all of our lesson, and we're ready to do some practice problems now. These are our 2 practice problems, and that's it. So this is a short lesson. So here we've got m squared hypotenuse squared equals the 2 legs squared. So 2 squared plus 3 squared added together. So m squared is 4 plus 9, which is 13. So m would be plus or minus the square root of 13, but we can't use the minus, so we will say m is the square root of 13. That's an equal sign. So now we look at this one. We have a p and a 7 and a 9. And this one is just like one of the problems we worked. We take the hypotenuse squared, and we add the 7 squared plus the p squared. We subtract, so basically this is 81. This is 49 plus p squared. We subtract the 49. We subtract the 49 from both sides. This becomes a 32, and we get p squared is 32, but we're going to use p, trying to find p, so we take the square root of 32, and we don't do the plus and minus because it's a side, so we just get the square root of 32. That's all there is to it. And this is Mrs. A, and may God bless your day. Have a good one.